Hold on, when it's September 3rd. Let's do this. We need to check the editorial for this one. Oh, so simple. O(n) squared. Yeah. Well, let's see what. Okay, so we have an easy problem, so we have to check it. Find the closest person, x, y, z, representing the position of three people, x, y, and z, who does not move. Both person 1 and 2 move toward 3 at the same speed. Determine which person reaches person 3 first. X, Y, Z. So Z, person 1 reaches first. So basically what you want is the absolute difference between Z and X and Z and Y. So this one will be 2. This one will be 0 if at the same time. Okay. You know what? I think this is easier to do. I can say return 1, D1 larger than D2. No, D1 smaller than D2. Well, return 1. Else D2 smaller than D1. 2. Else is 0. Oh. Okay, that's this. Alright, let's read yesterday. Preceding question. Yeah, we did this. Sort plus double loop enumeration. Yes. Yes. Can the extra loop be avoided? Okay, we sort points by their x-coordinate in ascending order. Now we perform an ordered traversal. So the points pair where n is the total number of pairs. Suppose A is the top left, then B must lie to the right and below. So the coordinates B must satisfy wait, hold on. A is top left. So B, that's true. Since the points are already sorted by X, the condition on XB is automatically satisfied. As we traverse B, is guaranteed to be non-decreasing. This leads to an important observation. If AB is a valid pair and later AB is also valid, if AB is valid and later AB B b2 larger than b1, and yb2 is larger than yb1. That's true. This observation is crucial. Once a legal bj is selected, the effective lower and the left boundaries shrink monotonically. Yes. Once we find one, the boundary shrinks. In other words, for the same AI, the set of valid bj extends in a monotonic fashion from the lower right and upward direction. Lower right, upward direction. Yes, this makes it possible to update the boundary dynamically while selecting valid pairs. So for each specific xbj, only the point with the highest y coordinate within the constraint range can be valid. Only the points with the highest y coordinate within the constraint range can be valid. Therefore, if we sort the points first by x ascending and then by y descending, the first valid bj encountered for a given AI will be the only one with the largest y on that x. Yes, by updating the lower left boundaries at this point, we can directly continue the search for the next valid bj. Hold on, what it's trying to say is we have, so we sort by descending, so the first thing we get is the highest. Then we get, then the next one we get, set the boundaries. Right, the next one we get, set the boundaries. So the next one we get must be bigger than this. So essentially, it's the same. Like we have, this is x, this is y. Right, we have something like this. So, and we sort on y decreasing. So this is the first one that we hit. So we say if this is the top left, right? And then the next one we hit is this. Then this one sets the upper bound. No, this one sets the lower bound on y, because it cannot be lower than that. So yeah, so this is good, right? And then once you're done on this one, you move on to the next one. It must be bigger than this, but it's not. So this one doesn't count. So you move to here. This one is good. These are bad. And then we update. It should be like this. You know what? I think we can try this one more time without reading the solution. So let's do 3027 again. $3027. All right, let's do this one more time. So this is from reading the. And now it looks very simple. So this solution is inspired by the editorial. I read through the explanation, but did not look at the implementation. Let's implement it ourselves. The idea is to sort points by x increasing and y decreasing. And for each points I, we consider it top left. then we go through the remaining points j to check if it can serve as the bottom right. The key observation is that once we find a point j that is valid, right, that is valid, its y serves as the lower bound, right, for any future valid points j. With this setup, we can do it. We can run it in O(n) log n plus n squared time. All right. So first things we need to do: sort points begin, points end, and then we need to pass connect to auto A and auto B. If A0 is equal to B0, return A1 larger than B1. So this is sort Y decreasing. Otherwise, return A0 smaller than B0. Sort X increasing. Okay, so now we first sort it. After we sort, okay, after we sort, we have a rest as here. I0 is smaller than points size I plus j I plus 1 j is smaller than points size j plus plus, right? So what we first do is to check if it's smaller. So we can say lower bound y, right, lower bound. So it has to be larger than the lower bound, and we can just say if points j1 is larger than lower bound y and points j1 smaller or equal to upper bound, which is points I1, right? So if it's larger than the lower bound and it's smaller or equal to the upper bound, then this is good. We say rest plus plus, right? And then lower bound y shall equal to points j1. Right? It's larger than the lower bound. Right, it's larger than the lower bound, and then smaller or equal to the upper bound, which is the points I, which is good, and then we keep moving. If it's not, we just ignore, and then once we're done and everything, we can just return rest. Let's try this. That looks significantly. Alright, so we have submission. We use test case. Give it a shot. Ooh, yeah. I don't think this one works. Has to be int min. Yep, that's the one. Yep, that's the one. $165. 25%. All right, now I'm curious. Let's do the same thing. This is from the better solution for problem 3027. Run it first. And submit. Yeah, 4 milliseconds. Good. All right, that was pretty nice. I'll see you guys tomorrow.